Morning, everybody. I'm Tim Darms here, talking to you from Charleston, South Carolina, and I am going to be showing you how to perform an iron jar test. This will indicate when we need to treat iron, as well as how we're going to be treating it. The basic setup is you're going to need a minimum of 5 jars. They can be nice glass graduated cylinders like this, or they could simply be Coca-Cola bottles that you've emptied out and rinsed out well. But you're going to want 5 because we're going to be needing to vary the amount of chlorine that we add to it so that we know how much chlorine we need to use to treat it. It's good to set them tight, close together like this with a white background. We didn't have a consistent white background, so I just took some pieces of paper and added it behind it. Anything you can do to have a consistent background is going to be helpful because we need to be able to see what the water looks like looking through it. Next, we're going to have to prepare our chlorine. You can use regular household bleach for this. Household bleach is very concentrated, too concentrated to be useful for us for a jar test, so we have to dilute it. In order to do that, just take your regular household bleach, some bottled water, a regular 1 liter bottle of water will be plenty. And what we're going to do is, we recommend you dilute it 5 times. So take a small container. I'm going to use the vial from the turbidity meter, and I'm going to fill this up with chlorine. I'm going to then dump it into here. I'm then going to ask Grace, one of our lovely interns for the summer, to give me some drinking water from here, just because it's heavy. I need some help. I'm not that strong. And then we're going to fill this bottle to the same place with drinking water 4 more times and dump it into here, because then we'll have 5 times dilution. 1 from here, 4 from there. So we'll go ahead and pour this out here. Remember where you're at. Dump it into this container. Then we're going to take the water. I'm going to fill it to the same location that I did the bleach. Same location. Once. Twice. Three times. 4 times. You can set all of that aside. Close the chlorine so you don't spill it. It's good to make sure anytime you mix something, you are going to stir it very well. So again, remember, we do 1 thing of chlorine, 4 things of drinking water. So that means the original volume of chlorine is now 5 times greater. So it's a dilution of 5. You're going to want to mix this very thoroughly. And then you're going to want to use, ideally, a dropper, something that you can deliver easily, 1 drop at a time. I have the syringe, and honestly a syringe is not the best. It's better to use a dropper, so it might be worth purchasing a dropper. We're going to take some of our chlorine solution. Again, I'm going to mix it up even now a little bit before. Make sure there's no chlorine on the side that's going to drip in. And jar 0 is going to get 0 drops. Jar 1, I have written down on there that I'm going to take 1 drop. Jar 2, written down, 2 drops. Important to write everything down and document it in the photographs. So jar 1 is going to have 1 drop. Jar 2, 1, 2. Jar 3, 1, 2, 3. Jar 4, 1, 2, 3, 4. Okay. And now if you're using a Coca-Cola bottle, put the cap on, shake it up real nicely. Do that for all the bottles, including jar 0. We don't have caps for this, so I'm going to use a stirring rod to mix these up, and Grace will give me a hand here too. You want to make sure that the chlorine works all throughout. Okay, and now what we want to be recording on this sheet are free chlorine concentrations in all the jars. You don't have to worry about jar 0 because that jar has no chlorine in it. So take a clean dropper or something so you can pull some water off of here and do your free chlorine as normal. Fill it up to your bottom line. Add your free chlorine powder pillow. You want to shake it and wait the prescribed time. 30 seconds. See how much free chlorine is still in there, because we want to be tracking on this piece of paper how much free chlorine is available in each jar. You can see here an example of the data and the sheet that's laid out. You have this jar name as well as the free chlorine content at each given time that you sample it. Here you can see the jars after about 15-20 minutes have passed. You can see a slight coloration in the jars that received more chlorine and practically zero coloration in jar 0, which received 0 chlorine. This is a great example from our Peru country program. You'll note most of the bottles have a nice white background behind them. Each bottle has a piece of paper placed in front of it that they're recording the free chlorine concentration over time. And you can really see just a really beautiful spectrum of colors as the iron is oxidized within the jar. Now the goal of the chlorine jar test is to help us determine how much chlorine is required to fully oxidize the iron that is in the water. The way we're going to tell that is twofold. One, we're going to visually inspect the jars to see if it has fully oxidized the iron. Sometimes that can be difficult though, such as the example from Peru, where you had a continuous spectrum of color. So what you're going to look at, secondly, is your free chlorine content. The correct amount of chlorine, you'll see, will start with a higher concentration of chlorine, and with time, that concentration of chlorine, of free chlorine, is going to diminish until you have just a trace amount of free chlorine. 0.2 is a great number because that means the chlorine has almost all been consumed by the iron, but not entirely, so we have just a little bit left over. If you had 0 free chlorine left, that could mean there might still be more iron in there, but there wasn't enough chlorine to fully oxidize it all because the free chlorine went to 0. Or if you had a chlorine content, let's say of 1 or 2, 2.0, that means we added too much chlorine, because even after the iron has consumed much of the free chlorine, we still have a lot of free chlorine left over. Next, you're going to want to prepare your jars for the alum jar test. For this, you're going to get 5 jars of your well water, whatever that source is, and you're going to add chlorine to all of them. This is very important that we add chlorine to these jars. The amount of chlorine is the amount of chlorine that you determined was appropriate based on your chlorine jar test. For this example, it was 2 drops of chlorine per 1 liter in the jar. You're also going to want to prepare a stock solution of alum. Best recommendation is to use 50 milliliters of granular alum into 1 liter of water. From there, jar 0 will receive 0 milliliters of this stock solution. Jar 1 will receive 1 milliliter of this stock solution. Jar 2, 2 milliliters, 3, 4, and so on. In order to measure out the volume of alum that you need in each jar, be sure to use a graduated cylinder or something that's going to allow you to easily and accurately measure and deliver the alum solution. In this example, I'm using a dropper in order to fill the graduated cylinder accurately, and then I use the graduated cylinder to deliver it into my jars. After the alum has been added to all jars according to their proper dosing, it's important to mix. In this case, I'm using a glass rod to stir the solution, but in the field you'll most likely be using bottles with caps. Put the cap on the bottle and gently shake the bottle so that the alum works all throughout the solution. After this has been mixed thoroughly, you can set the jars down, again against a white background, and start recording time and taking photographs illustrating the changes in the water with respect to time. You can see here that the jars on the right are more cloudy than the jars on the left. This is because the jars on the right received more alum than those on the left. Drawing a line in the background can help you see when solutions are beginning to get cloudy. After some time, you'll see that more solids begin to accumulate at the bottom of the jars with the proper alum dose. One good way of visually verifying that the iron has settled out of the jars is to use a light that you place behind the jars. This allows you to see how cloudy the water is and to really see each individual particle of flocculation. If the settling has fully occurred, next we want to test the iron content in our jars. If we're designing an iron removal system, we ought to be able to remove the iron in the jars itself. You want to perform an iron jar test the same way you would an ordinary iron test. The only difference is you should use a syringe, as shown, to sample water just off of the top of the jar. The reason for this is that iron test strips that we have test for total iron, meaning it will show results for both dissolved iron as well as suspended iron. So if there's iron that has not fully settled, it will appear in the test results. By taking a sample just off of the top of the jars, this helps ensure that we're only collecting the water that has fully precipitated the iron. It's always good to review the timing and instructions on all of your water quality test kits, as the amount of time varies between shaking your powder pillow and the amount of time that you submerge your test strip. You can see in this photograph that the iron content of the sample before testing was pretty high, about 4 milligrams per liter. This photograph shows the iron content after chlorination and alum settling. The iron content is about 0.15. This iron content should not pose any problems to the LWTS in the treatment system. This concludes the iron jar test video.